Here's number 5 from the fall 2010 EF 151 exam 1. We are looking at determining the angle from the reference line. Angle T from the reference line is shown. So hopefully you recognize this one as one that's similar to a homework problem. Should also recognize that we have a triangle, vectors added head to tail, and we know one included angle, this angle right here, and we know two sides, so that will completely define the triangle. We need to find this small angle in here and then subtract that from 180 to get the angle shown as T. So that's our plan of action to get that small angle. Let's see, we got law of sines and law of cosines. We don't know the length of this red side right here, so we can't really use law of sines in one step because we don't know the other angles and don't know the side opposite the one angle we do know. So we're going to have to use law of cosines first. So law of cosines requires you to know, has information about three sides and one angle. So I'm going to have to use this as my C and my other two sides and my included angle to get that line C there. So C squared is equal to 10.9 squared. 10.9 squared is one side. 16 squared is the other side. Minus 10.9 times 16 times the cosine 113. Alright, so over here 10.9 squared plus 16 squared. Why aren't isn't my calculator working here? 10, there we go. 10.9 squared plus 16 squared minus 10.9 times 16 times cosine 113. Double check my numbers. Looks good. So there's that, and I'll take the square root of the second square root. So my answer 21.046. C equals 21.046. That's going to be units of meters. Alright, so now if we call this theta, we can use law of sines. Sine of theta over 10.9, opposite side, is equal to sine of 113 over its opposite side, 21.046. Alright, 21.046 was my answer from before, so I'm going to do sine 113 divided by answer times 10.9. That's the sine of theta. So I'll do the inverse sine of that answer, and I get 28.5 degrees. Okay, based on everything else, that thing's drawn about to scale, so that looks like a reasonable answer. Four vectors shown are in equilibrium. Determine the angle theta. We've worked lots of problems like this. With more than four vectors, we've always used components, and we've always set up a sort of table. So let's do that. Alright, so my table is going to have a vector A going to the left, a vector of 240 degrees going up at 65, okay, a vector of 240 pounds, 420 pounds going up at an angle of theta. So there's one of our unknowns. A is our other unknown. And a vector of 550 pounds going down. I get x and y components of these. I don't know a, but it's going to be a minus a and a 0. This one's going in a negative x direction. It's going 240. The x is adjacent to the 65. So that's going to be cosine 65. It's going up, so it's a positive 240 sine 65. Alright, almost there. 420. It's going to the right. Cosine theta. Don't know that. And it's going up. 420 sine theta. Okay, and our last vector, 0 in the x minus 550 in the y. So be careful with signs and be careful with your trig functions. Okay, all those add up to 0 in the x, 0 in the y, because it's in equilibrium. If I want to solve for theta, I can do it from this second equation right here, because there's only theta. A does not appear in that one. So basically we're solving for theta by looking at the components in the y direction. So let's write that out. I would use my solver for this one. So I'm going to write out what I'm going to plug into my solver. I'm going to come over here, clear everything. Math 0. I've already got that cleared out, so I'll just plug in my equation. Sine 65 sine x minus 550. Alright, I'm going to guess theta, say 60 degrees. The starting value, alpha, and it gives me 52.3 degrees. No algebra, just using the solver. This is fine, you don't have to show intermediate algebra steps. Don't have to solve for A if it's not asked for. Alright, let's stop this one.